Assalamualaikum and welcome to another help session for your final year project or FYP. This session will describe the requirements, the process and the procedure for undertaking your final year project that requires finite element analysis or finite element simulation. This session is intended to help you with a systematic process in completing your FYP with finite element simulation works. We have arranged the content so that you can learn adequate concept and understanding on how the mechanics of materials, how the materials engineering and materials science aspects are idealized for finite element simulation, and how the physics are then introduced back correctly into the finite element results. We present the guide, but it is not a manual for running your FEA software for specific projects. However, it is universal and independent of any FEA software that you plan to use. As a prerequisite to running finite element simulation, it is good to review your solid mechanics courses for solid mechanics problem, static, solid 1, solid 2, and recall your knowledge on math, differential equation, and matrix algebra, and good to have idea on the problem that requires a solution. And familiarity with engineering design process is an advantage, and most of all have lots and lots of common senses to exercise. If your FYP requires you to perform finite element simulation, then you must have access to FEA software, preferably installed in your PC. The university hosts Abacus and ANSYS FEA software that you can access. You must also learn and know how to run the software, and for this, you can start with the software manual. Let's talk about simulation. It is the representation of physical phenomena such as bending of beams, buckling of columns, heat transfer across brick walls, and laminar flow over cylinder. Simulation is done by experimental, analytical, or computational methods, and finite element method is one of the computational approach. What is finite element analysis? Most people refer to it as a colorful graphical tool. Some consider as an example of garbage submitted for analysis, garbage calculated for the results. But it could also be a powerful stress analysis tool to solve boundary value problems. And you, as an engineer, should consider finite element analysis as a thinking tool. Finite element method is a numerical analysis technique for obtaining approximate, not exact, solution of a variety of engineering problems. And we illustrate here finite element analysis prediction of stresses in steel wire ropes subjected to axial loading. The basic premise of the finite element method is that a solution region can be approximated by replacing it with an assemblage of elements. The unknown field variables such as displacement are then expressed in terms of interpolating function within each element. Interpolation functions, which are central to the finite element method, are discussed in your finite element analysis course. This slide illustrates the solution approach to heat conduction problem by the finite element method. Analytical solution or exact solution is known for the given boundary condition. And finite element method discretizes the solution domain into finite number of nodes across the thickness. And a linear set of algebraic equations are then assembled for solving the unknown nodal temperatures. Let us now look at the big picture on problem solving by the finite element simulation. As an illustration, we consider a complex system of V8 engine. The sub-assembly of concern is the crankshaft, connecting rod, and piston assembly. And the problem is identified as to determine the deformation and stress field in the connecting rod during operation of the engine. And this is an example of a solid mechanics problem.